Thanks for having me. I'm going to stop my video because I'll be honest, when I do these virtual presentations and I have slides, I get distracted seeing myself and my slide at the same time. There are fewer people than I anticipated, so if people have any thoughts or questions, feel free to interrupt me and ask. Happy to make this more interactive. I do have some quiz questions too, so occasionally we'll stop for those. I'm not able to see the chat where people can put their answers, but feel free to put them in. And hopefully you guys can share them with me and we can go over them if there's any confusion. But as he said, Dr. Sydney Crawley, I'm at Rentokil Terminix. Here's my contact information if anyone wants to get a hold of me. And I wanted to set an agenda. I really like knowing where I am in a presentation. So hopefully this orients you a little bit. I want to go over a brief intro just into bed bugs, their biology and behavior. I think that's really important for effective management, understanding how they behave, what they need to thrive, so that we can kind of manipulate those things for best practices. Talk about the pesticide resistance problem, why some strains of bed bugs are so difficult to kill and what you can do to circumvent that. Talk about the difference between proactive and reactive management. Try to be as industry relevant as possible because I'm aware that proactive management is pretty tough in some cases. And we'll end with what I think are the current best practices that are affordable, sustainable, and actually executable, because I know some of the academic protocols are pretty tough to execute on a broad scale and in a bigger service model. I'd really like you guys to leave today understanding just the basics, the bed bug basics, we'll call it, their chemical ecology, their biology, and their behavior. I really want you to understand how resistance can impact the management of bed bugs and what to look out for in case you're dealing with a resistant population. Understand the differences between a proactive and reactive approach, and then define and describe previously established and what I call the new and current best practices for bed bug management. So with that, we'll hop right into an introduction. So historically, I'm sure everyone's aware of this, but insecticides were, and they kind of still are, the predominant way to kill bed bugs. But historically, I mean, that was it. Outside of physically, squashing them, it was the way to go. In the 1800s, the 1900s, the most common way that people dealt with a bed bug problem was with extremely toxic compounds like arsenic, mercury, and kerosene, things that you really don't want to throw around your home. Sulfur treatments and cyanide gas were also common, but that's obviously really problematic, right, for human health. So we don't do those sorts of things anymore. Pyrethrum eventually was also used, which of course we're aware of now as kind of a safer, natural alternative for pest control. It is still widely used. That's the natural precursor, by the way, to synthetic pyrethroids. Pyrethrum is extracted from chrysanthemums. And although it has a lower toxicity, pyrethrum, it doesn't have any residual activity. And so that, it was basically about the same as arsenic, mercury, and some of the other things that only worked on contact. And direct application of pesticides for bed bugs is not that effective because they're insects that are really good at hiding. And so it's hard to make direct contact with every single bug. I'd love to say the current problem is really different than that historical problem, but it's kind of not. And, in spite of all this research between, when we had a resurgence in the late 90s, research really started in 2006 on how to control them, even though we started seeing bed bugs again in the 1990s. The current bed bug problem that we have is probably not going to resolve anytime soon and presents the same exact challenges as bed bugs did in the 1900s. The only major difference is that the current populations that we have today are extremely resistant to pyrethroid and even neonicotinoid compounds. And they're exceptionally hard to kill using just liquid chemicals, unless you're dealing with a rare, completely susceptible population. And because they are so difficult to manage with a widely available technology like chemical pesticides, populations are still on the rise, or at least plateauing in most nations. So other issues to defining and assessing what to do with this big bed bug problem that we have. Part of it is that the resurgence and the reasons why it happened are still poorly defined. It's difficult to get data associated with a bed bug introduction or an infestation through things like surveys, because hospitality folks, restaurants, people that work for the public, they aren't necessarily motivated to share when they have a problem, because of course their reputation is important to protect. And if we can't get data regarding how they're spreading, where they're spreading, and when, it makes it difficult to go to funding agencies like the NSF or NIH or granting folks and say, hey, we have this really big problem. We need technological advances to deal with it. If we don't have that data, it's tough to get that funding. So that's gotten us into this situation where we have this widespread problem without a silver bullet that could really solve it. And in spite of that, especially, in the early 2000s, industry provided a lot of funding, pesticide manufacturers, to research that would help develop products to manage this issue. We do have enough technology to, I think, control and eradicate populations of bed bugs for sure. It just can be labor intensive and expensive, right? Technology is cost prohibitive, sometimes difficult to integrate into a service model that makes sense. And I think that's a big reason why we still see populations pop up so readily. So I want to spend most of the presentation, filling in those gaps between pre and post resurgence, and I'll define what I think are the best ways to deal with, quote unquote, a modern bedbug infestation. With that, if no one has any questions, and again, feel free to just cut me off if there are questions. We'll go into some of the basic biology. Again, hoping that most people are familiar with this. I'm not going to spend a ton of time on it, but bed bugs are obligate blood feeders. So unlike mosquitoes, where you have only one sex taking a blood meal, each life stage and each sex, both males and females, need to take blood in order to either molt and move through the life stages or lay eggs and produce sperm. And the species of bed bugs that attack humans, Cymex lectularius, are pretty host specific. And that's true of the family of Simissids in general. There are definitely more species of quote unquote bed bugs than the ones that attack humans. So the ones that attack humans are in the genus Cymex and include lectularius and hemipterus. And hemipterus are tropical bed bugs. So those are more common in the southern US. Some other species will feed on chickens, bats, birds, and other mammals. But if you are truly dealing with a bed bug population, so lectularius or hemipterus, they are not likely to feed on pets and other animals. I'm not saying they never will, but it's pretty unlikely. And regardless of what other species you're talking about, bed bugs have 5 nymphal stages before they reach adulthood. First instars are the life stage that's most susceptible to desiccation and death. They will die pretty quick if a blood meal is not found within a reasonable amount of time. These insects feed once every 3 to 7 days, depending on how complete of a blood meal that they took. And it takes about 5 to 20 minutes to feed to completion. They are all flightless. They do not fly. They do not jump. They only crawl. They live in dense aggregations in really cryptic spaces. And they're very thigmotaxic. And what that means is they like to be touched on all sides when they are resting. And they also avoid light. So they like to hide tightly packed together in dark spaces. After females take a blood meal, it takes 2 to 5 days to lay eggs. And she can lay a few hundred eggs over the course of her life. And bugs that live in the same space are typically related, but they're very tolerant of inbreeding, unlike, say, termites, who don't like to necessarily breed with brothers, sisters, moms, dads. So like I said before, I just wanted to show some pictures. There are different types of bed bugs. There's over 100 species of quote unquote bed bugs. So that term can be a little bit confusing. And lectularius, again, and hemipterus are the bed bugs that you're going to see in an account most often. But there are other species that you might want to be aware of in case you run across them, because an improper ID could potentially lead to a failed treatment. So other species will parasitize, like I said, bats, birds, chickens. Western and eastern bat bugs will attack bats, and swallow bugs, which is in the middle of the slide toward the bottom, will parasitize swallows. So always make sure you have the correct pest ID. You're most often going to see lectularius, maybe hemipterus, but I have been in accounts where people think they're dealing with bed bugs, and they are actually dealing with a bat bug. And if you're having trouble with the ID or they look slightly different, feel free to send it in to an extension group, or you reach out to me if you'd like. People will always be like very willing to ID from photos. Just make sure the picture is as clear as can be, or ideally grab a specimen. How do they feed? So this is a really important topic because it relates back to things like building a bedbug monitor or a bedbug trap that works really well, which I'll get into in a bit. That's the most common question I get is can we build a bedbug trap? And I do want to spend some time talking about that. And this is relevant to that topic. So the cues that get a bedbug to leave an aggregation and try to find a host, we still don't really understand that process from soup to nuts, so to speak. We don't really know how they're doing that in a clear way. We do know a few things. We know they're more active at night, or at least they show periodicity, which is activity expressed during a certain time of day. And they also follow circadian rhythm, just like humans do. So that means they follow a 24-hour sleep pattern. That also impacts their digestion, their movement, a lot of different behaviors. But being nocturnal allows bedbugs to feed when hosts are, inactive, less likely to see them. But if someone sleeps during the day and is awake at night, they will flip their periodicity and they'll become active during the day and, go back to aggregations during the night. Studies have shown that they can indeed detect carbon dioxide and other odors like sweat and heat, just like mosquitoes. But the accuracy and how strong they respond to those cues and signals is really variable. I think that most people think bedbugs are attracted to carbon dioxide, but from my work and a few others, it looks like CO2 serves as more of like an activity activator. So it stimulates them to move around, but it doesn't necessarily direct them with any sort of accuracy. And they can detect host odors and CO2 from several meters away, but that doesn't mean that they're going to get to the host with any accuracy. What seems to give them a really great orientation ability is heat, but their ability to detect heat is very short range, 3 centimeters or less. That will also cause them to start probing, and the antennae are responsible for that behavior. So the antennae detect heat from a very close range, and then their proboscis, you'll see they try to start probing to find blood. We think that the reason that bedbugs are less accurate in host finding than, say, mosquitoes is because they tend to harbor very close to their hosts. And so they don't need to travel a great distance to orient. Many of the smell receptors, we'll call them, that other blood feeding insects have just aren't present anymore in bedbugs, which makes sense. So for example, male moths have 60,000 odor receptors on their antennae. Bedbugs have a measly 54. And that's a stark difference. And so that's probably related to why they have trouble orienting. I know it seems like they're really accurate when you're dealing with an infestation, but if you got 1 or 2 lone bugs, I've seen them in such random areas of the home, nowhere near where people are sleeping. So they're not heat-seeking missiles. And we know that they will still feed without heat, and you can even remove their antennae and they'll still feed. So we just don't fully understand how they are, in fact, detecting host presence. So with that, we'll pause for a quick quiz question. Which feeding cue is a locomotor stimulant for bedbugs? So again, this is something that gets them moving around, but doesn't necessarily orient them in any direction. So A, carbon dioxide, B, sweat, C, heat, or D, sebum. Hopefully there's answers being put in the chat. And if you answered A, that would be the correct answer. So host seeking for bedbugs, like I said, way less straightforward than other blood feeding pests. It's even less studied, I would say, than a lot of other hematophagous insects. There are, like I said, a few stimuli that they respond to when looking for a host. Heat, like I said, really responsible for activation of orientation, movement toward the host, and the actual feeding initiation process. However, the physiological state, this is important to keep in mind too. that a bed bug is in when it's time to feed can also determine how intensely and accurately that they forage. I've tried to give a graphical example of that on the right-hand side of the screen. So the green arrow pointing toward the host and the cues you see on the left, those are things that'll get bed bugs moving toward a host. The red arrow pointing down toward shelter and the cues to the right, which look like they might have got cut off a little bit, I apologize. Those are cues that will push bugs back into the aggregation. So for instance, the mating status of a female. If a female has been mated, she's probably more likely to orient to human odors. And that makes sense because she is now capable of laying eggs. She needs blood to support the development of those eggs. So she might be more likely to take a blood meal than an unmated female. Starvation can impact the foraging process too, in kind of an interesting way. So if unmated females are starved, they are more likely than mated females to move toward a host. But if that goes on too long and bed bugs have been starved for a very extensive period of time, they are actually less likely to move than bed bugs that have fed more recently. That's probably so they can conserve energy and only make a foraging attempt when they are absolutely sure that a host is nearby. So factors outside of a host being present or not can also impact whether or not a bed bug leaves their shelter. And so again, I hope your brain is kind of turning on like, oh, wow, it would be really difficult to have a trap or a detector of some kind that's active, that contains cues or heat or CO2 that's accurate 100% of the time. Just based on all of these things that I've shared, it can be really difficult. And I have a slide like focusing on that later, so I don't want to get too much into it now, but it's just a topic I find very interesting. So when bed bugs aren't feeding or host seeking, they spend a lot of time forming these really large groups in hidden areas out of sight, out of mind from their hosts. That is, unless an infestation gets to the point where those optimal harborage spots right near the host are taken up, then you have to deal with what you see on the right-hand side of the screen. This is in an infestation I saw in a multi-unit apartment facility. I saw that sort of aggregation evidence all over the home, right on the walls, freestanding aggregations just on the wall. It's beneficial for bed bugs to get into these aggregations because the microclimate is different and less dry. So nymphs can develop more quickly because they have more moisture, and that allows them to get through that most vulnerable point in their life a lot faster. They also lose less water. So when they take a blood meal, it allows them to keep all of that nutrition, all of that water. It keeps them from drying out. So when they're not host finding, or if a host isn't present, it's very beneficial to have that slowed water loss because water is very important to their survival. Granted, they can withstand desiccation a lot better than a lot of insects, but they do still need to have some sort of moisture. So within the fecal spots that you see very clearly in the picture are aggregation pheromone. That aggregation pheromone smells kind of sweet or nutty to humans, but the message it's communicating to other bed bugs is that, hey, this is a safe space, this is a good place to be, and that scent is reinforced by touch. So once bed bugs arrive and orient to that scent, if other bed bugs are present, they're more likely to stay there because of that thigmotactic reaction. So they like other insects being pressed up against their bodies. And so again, just going back, I want to keep reinforcing this because again, I get this question probably once a day, like, why don't we have a really great bed bug trap? Obviously, because of the thigmotactic preference, if other insects are present, they are more likely to establish an aggregation. And another question I get that I want to circumvent or at least get ahead of is there any site fidelity? So once they form an aggregation, do they always go back to that same aggregation? And the answer is no. They will readily go into another aggregation without hesitancy. With that, again, if there are no questions, I want to talk a bit about the resistance issue. So in the 18 and 1900s, quote unquote exterminators, that's what they were called then. We don't use that terminology so much anymore, but They relied on toxic sprays made of compounds like arsenic and mercury, like I said. They were extremely toxic. They killed everything they touched, but they offered no residual protection. So that's a huge problem because, like we said before, you can't kill every bed bug directly. If we could, I don't think we'd have such a problem. So if you could kill every bug directly, there'd be no insects left behind to reproduce, right? But when you spray a residual compound like DDT, DDT was huge, and it really slowed down the spread of bed bugs in like the 1950s. But very quickly, within 5 years of its introduction, people started noting resistant populations. And so that's tough because DDT is very similar to our synthetic pyrethroids, and due to cross resistance, you've got resistance to our current products. And then now that we've been using our current products for a long time, and you can see on the right-hand side, you're probably familiar with how the evolution of resistance works. You spray a population, just by random chance, you're going to have resistant insects, even if they haven't been exposed. You spray the compound, all that's left would be your resistant bugs. Those resistant bugs produce more resistant insects. Occasionally they'll produce susceptible bugs, but ultimately you end up with a population that's really, really difficult to kill. And that's the situation we're in now, where pyrethroid resistance is widespread. And now we're starting to see resistance to neonicotinoids as well. And to make that problem worse, bed bugs have more than one way that they pesticide proof themselves. And some of these mechanisms are unique to bed bugs. So first of all, a resistant population might have higher levels of enzymes that can actually detoxify insecticidal compounds. So those are enzymes that take in the chemical, they turn it into something harmless, and then it's excreted through the digestive system. The second way that they can pesticide proof is by thickening their cuticles. So cuticles that are thicker, obviously an insecticide would have a harder time penetrating that waxy layer and getting to the cells that it needs to get to in order to cause mortality. And what's unique to bed bugs than some other pests is within that cuticle layer houses some of those detoxification enzymes. So a lot of times for other pests, those detox enzymes are in the hemolymph, or they're in the gut, so further within the insect. Bed bugs have those enzymes like right on the outside. So not only do you have a thicker cuticle that's harder to penetrate, but as soon as the pesticide does get in, immediately they're met with detoxification enzymes. So it's like a 1-2 punch kind of system. And on top of that, let's say pesticide does enter the body more fully, gets into the hemolymph, gets into the gut. There are cells present in resistant populations that they can block pesticides, they can block binding to the receptors that they need to get to be efficacious. Most bed bugs in the US, as many as 88% of populations that we see, have at least one of these genetic mutations that leads to one of these type of resistance. And most of the time they have multiple. I've seen lab populations that are up to, we can't even measure how resistant they are because they are so resistant. We're talking 1,000,000+ times more resistant to a pyrethroid than a susceptible population. With that, we'll pause for another quiz question. A thicker blank prevents pesticides from entering bed bugs as readily. A, enzymes, B, stomach acids, C, nerve cells, or D, cuticle. Those who said cuticle would be correct. Right, so it's been kind of doom and gloom up to this point. So we've talked about biology, behavior, things that make them difficult to manage with either chemical insecticides, pieces of their physiology that make them difficult to capture in any sort of passive or active monitor. But now I want to talk about some things that we can do, ways that we can proactively get around even, developing an infestation in the first place, because we know the sooner you can detect a bed bug problem, the sooner you can start treating it, the quicker you can get rid of them. and the less labor that's required to do so. So obviously I know, and we know, you can't completely prevent a bed bug problem, especially if people are introducing them from an outside source, or if you've got movement from one apartment complex to the other. That's not the tenant or the resident's fault. And it just happens, right? So it's never going to be completely preventable, but there are things we can do for customers to try to decrease the potential for introductions. We know that detecting bed bugs early is difficult, but there are things that you can do that make it possible. We can also limit the spread of bed bugs to new locations through education. We can try multi-pronged approaches. This integrated pest management system, which everybody knows we're trying to migrate to IPM for all structural pests. These systems are intensive, but depending on the account, this sort of approach could actually be lower costs, lower labor in the long term. And education, that's just one of the best ways to prevent introduction and establishment of bed bugs. I think we should always be trying to deliver some piece of educational information to our customers, especially to individuals that are probably vulnerable to an infestation as it stands. So like an Airbnb owner, a hotel chain, nursing home personnel. These people are kind of at the front lines, right? And there are an array of topics that you can cover, and hopefully these things are easy for the customer to retain. I've seen good progress working with people on these topics and getting them to understand, be more aware, and be more involved. You're not always going to have that luxury, but I have seen it work. Correctly identifying a bed bug, though, I think that's the most important skill for people to have, so that there's no panic over something that's not a problem, and there is awareness when you do have a problem. So educate customers on what a bed bug looks like, what behaviors they exhibit, and relatedly, they should be aware of the signs of bed bug activity as well. So shed skins, fecal spots, blood spotting. You can talk about skin reactions or bite reactions, but because not everyone reacts to a bite, or people react differently, it's not a great indicator, but you can definitely go over it. Seeing shed skins, I would say it's one of the first things that my customers have noticed. Fecal spots, definitely another. And then when it gets really bad, they start seeing insects everywhere. They should be aware of how to perform their own inspections as well. So give them the tips and tricks that you use. So I like to use a bright flashlight and a credit card. And I just pull back mattress ticking, tell them the best places to look. And that might always just be, it might not always be right around the bed. So electrical outlets, cracks and crevices in baseboards, other bedroom furniture. Obviously, you can tell them to start at the bed and move outward. And make sure that they're aware. Some people have not understood this in the past. Help them understand that bed bugs can be passively transported on used items, or even on their person, if they visit an area that has an active bed bug problem. And encourage your customer to have a pretty standardized protocol for when a bed bug is found. So, if they are someone in a hotel, or if they are in an assisted living facility, like who does the resident tell? Where do they go to get help? Do they take a specimen? Help them make people feel comfortable talking about this, and like it's not something to be ashamed of. That helps us get at the problem really early, before it gets out of control. Monitoring is another way to be proactive, but we've talked about this. Number one, I know it's tricky for some people. I've had clients that, just don't want to use a climb up. They don't want to use a monitor because, they think that it shows the customer that they have an active problem. So that's not ideal for some customers. But unfortunately, we do know through research that this is one of the best ways to detect bed bugs early. It's also a great way to verify if a treatment has worked. So you don't need fancy traps to do this. Passive pitfall style monitors are really effective. But again, I acknowledge they are not the most aesthetically pleasing thing. They also don't always fit well under all legs of furniture. These are supposed to be placed under the legs of like bedposts. Obviously, this isn't going to work for something like a recliner. So when people sleep in a recliner, there may not be legs that you can put these underneath. And they do work out in the open, but it's definitely better when they're placed as they're intended. These also require frequent checking to work best. And again, I know that's hard to do on some service intervals. I think one of the biggest things that's missing from a product perspective for bed bug management is an easily deployable, really discreet, really effective, cost appropriate monitor. People are working on this, but we've gone over the hurdles and why it's not necessarily easy to achieve. So anyway, like, again, I think monitoring is important. We know you can use monitors with Cymexa to eliminate a population. Usually it takes 6 weeks or more, depending on how dense it is. They are documented as being more effective than dogs, resident complaints, visual inspections, some of the more standard ways that we typically detect bed bugs. But I'm not going to pretend like there aren't issues with using them in many of our accounts. Mattress encasements, also a great way to prevent bed bugs from establishing, to see them really early. And even you can trap bed bugs inside box springs using these, or a mattress. White is the best color. That way you can see activity really easily. And this is great because then the customer can keep their furniture and they can feel safe doing so. They must have the proper zipper with tightly interlocking teeth. The zipper has to secure at the ends. They have to be tear resistant. There cannot be folds and there can't be any loose hanging areas. This is really important to communicate to the customer because, again, as intuitive as these may seem to us, I've had many, many people use them and not understand that they don't work if they get holes in them or if the zipper isn't zipped all the way. So make sure that you explain how to use these because they're pretty expensive. And so the customer needs to be aware of how they're best used. I really like desiccant dust as well. These can serve as a physical barrier between connected rooms within a residence or in an office or an apartment setting. This can prevent bed bugs from moving to and from areas and infesting new parts of a structure because desiccant dusts are mechanical. And, as far as we know, as of now, bed bugs are not resistant to these at all. So they should work as long as they get a good enough dose and they crawl over the deposits. I think it's great to protect susceptible areas using a dust. And you guys probably know how to apply this, but obviously you want to keep it light. There does not need to be piles and piles of white dust all over the dwelling. You can apply this to tacking strips, baseboards, wall voids. It's not ideal to apply it out in the open and high traffic areas because the dust will, move around and it won't settle properly. You don't want to put it in areas with lots of airflow, but desiccant dusts are effective as long as they stay in place. And I will make a case here for silica gel over DE. They are different. They work slightly differently. It has to do with adsorption versus absorption, and it has to do with how each of them work on the cuticle. So silica gel actually kind of absorbs the wax that's on the outside of a bed bug. That wax is gone. They lose the ability to regulate water, and so they dry out. Whereas DE makes small cuts in the cuticle, allowing the water to leach out, and they dry out. For whatever reason, in a field setting, silica gel, in my experience, has been much more efficacious than DE. You can get DE to work in the lab, but I think in the field, silica gel is a better choice.
Dr.
And
Crawley,
finally, yeah, go ahead.
you were talking earlier in the slide about their ability to be resistant to insecticides, and you had mentioned also the thickening of the chitin. Is there some of those the thickening of the exoskeleton and such that excuse me, that makes them more or less susceptible to the desiccant dust?
Yeah, that's a great question. I've seen one paper published on this topic. It took longer to kill bed bugs with the thickened cuticle, but it still worked. So as of right now, I haven't seen full-blown resistance, but you're right. At some point, there is a potential risk that cuticles could get thick or resistant enough to inhibit the efficacy of a desiccant dust, but I don't think we're there yet.
Okay, great.
Unless a paper has come out very recently that I'm behind on, but I don't think that's the case. Great question. Heat, another effective way to treat potentially infested items before, an full-blown infestation can occur. We're all aware of this one: clothing, furniture, electronics, other portable belongings. The thermal death point is 122, and that's all life stages, and they need at least 1 minute of exposure at that temperature to die. High heat of most dryers will reach that thermal death point, but you need to pack loose and there needs to be room for airflow. Portable heat chambers are great. I know they're, pretty expensive, so that might not be a great option in some cases. And obviously it only works for the bugs that are present. So when I say that heat is a good way to prevent bed bugs, what I mean is it will prevent introduced bugs from being able to produce a full-blown infestation. So it's not preventative in the sense that it'll, prevent bugs from entering when they're not there. So I just want to clear that up. But again, 122F, 60 seconds. This can be achieved 2 cycles, high heat. If you're advising customers to launder, make sure you tell them that clothes should ideally go into the dryer first before they're even washed. Heat works much better than laundering with water. Okay, another quiz question. The thermal death point for bed bugs after 60-second exposure is A, 120, B, 122, C, 130, or D, 110.
So while everybody's answering that question,
Yeah.
what is a typical home? You said 2 heat cycle, I think is the way you defined it. So your most home dryers will reach this thermal death point?
Yes, after 2 cycles.
2 cycles.
Yeah.
Is that actually mean? And I think some of us may not be quite as familiar with our drying cycles. We just do it and move on. Is that actually a setting on your dryer, or is it actually truly putting it through like a second run through?
I recommend people set high heat,
Uh-huh.
run that for 2 full cycles just to be, it probably is, 1 is probably enough, but it's one of those things where, like, in this case, more is truly better without doing any harm.
Yep. Okay.
Right? Unlike, a liquid pesticide, like, oh, more is better, so I'm gonna over apply. In the case of heat, you can't really over apply it, right? The only potentially harmful thing would be if you have clothes that are,
Sure.
sensitive to high heat. That would be the only limiting factor.
Okay. Great.
So those of you that said 122 would have been correct on that one. Getting close to the end. Looks like we're running on time, so that's great. Obviously, the way that we typically deal with a bed bug problem is in a reactive way. I'm again, as much as I would love to say everyone needs to be proactive, everyone needs to take these proactive approaches. Again, I'm very aware that most people don't really have interest in paying for that service, or they're not interested in dealing with it until there's an actual problem. So say you've done an inspection or the customer has shown you a specimen and bed bugs are present, what do you do, right? A lot of companies have their own SOPs, which is completely fine, but a few things I think remain the same for everybody. So first, you want to keep the customer, client, whoever you're dealing with, you want to keep them from panicking as much as you possibly can, because what tends to happen when people panic is they start doing things on their own that are either harmful to them, harmful to pets, harmful to the environment, or actually could be counterproductive to the treatment protocol that you are going to enforce. Remind them that even the worst of the worst infestations can typically be managed with, just a proper IPM treatment plan. And a combination of management strategies, which we've already kind of talked about, as well as some additional tactics I want to go over now, are what works best. So chemical, non-chemical, reactive, and proactive measures are going to be best when paired together to manage most bed bug problems. Sometimes things are so out of control, you have to do something extreme like a whole building or whole home fumigation, but hopefully that's rare. And then, of course, the strategies that we talk about need to be tailored to the environment. So dealing with one bed bug in an elementary school is completely different than dealing with 10,000 bed bugs in a hotel, right? So, non-chemical methods, I've seen a huge demand for these sorts of services. People are becoming less accepting of liquid pesticides in the home. I will say though, when you mentioned bed bugs, all of that seems to go out the window. People are really hesitant about it until you say that they have bed bugs, and then they want you to use whatever you can to deal with the problem. But a lot of people have been asking for things like heat, green, quote unquote, chemicals. I don't really love using that term, but that's probably what the customer will ask you for. I think heat and some of these non-chemical methods can be a great way to cut a high density population down really quickly. So steam, heat, these things that can be dangerous. Obviously, doing a heat treatment without the help of a professional can be super dangerous. So make sure you remind the customer of that. But the thing is they are also pretty expensive. But if you have someone that's willing to pay, and you have the equipment and you have the trained labor and the staff, I think it's a great alternative to consider, depending on the account. Again, we tend to only use this when the infestation is very, very severe, and we just kind of need to get a handle on it before we apply a chemical treatment. So pesticides, as we said before, the problem hasn't really changed since the 1900s. Pesticides are still often necessary to completely eradicate an infestation of bed bugs. Not always. You can use non-chemical alone, but often in that case, you really have to have customer cooperation. So I had a friend who had a pretty bad infestation, and I worked with her to deal with it. She was a single mother. She couldn't really afford a professional treatment. She and I, working together, were able to eliminate it using just climb-ups, Cymexa, and mattress encasements. However, I had to go over there every 2 days. And a lot of people, like obviously a technician is not able to get out to a home every day or every couple days. Often you don't have customer cooperation. That being the case, you typically do have to apply some sort of liquid or desiccant pesticide. Some of the most effective chemicals I've seen in the lab setting, we can't use in the field because of environmental and human safety concerns. But what we can use are usually a combination of pyrethroids, neonics, pyrols, and some inorganic compounds. Most of our liquid sprays, which is the most common formulation that we use, they're applied for residual control. We want to get a toxic residue on substrates that will kill bed bugs for days or hopefully weeks. Most products claim 2 weeks or more. I don't necessarily know that that's always, accurate. It just depends on the situation. Most of the major classes that we have are going to take, or most of the common products that we have, are going to be a pyrethroid and a neonic, or more than one pyrethroid. This will increase the odds of efficacy, right? Because you're attacking more than one type of nerve cell. And you can apply these in, some open areas, cracks and crevices. You want to try to hit where bed bugs are hiding. These are they still are the mainstay right now for bed bug management and control. Typically, these have a reapplication period of about 2 weeks. By the way, little qualifier, any product that I put on the screen, not an endorsement, just I went to Google and pulled some of the most common products that I saw. Every company tends to have their own APL. So I know that people are going to use what's usually a company standard. Another option is a pressurized aerosol. These are self-contained. They emit a spray spray in a liquid droplet form. Those droplets are smaller than what you get from like an RTS, RTU, or another liquid formula. These are usually, for whatever reason, I haven't published this work yet. I need to do that. But when I tried aerosols versus liquids, usually they're more effective, even if the active ingredients are the same between the pressurized aerosol and another, like a suspension concentrate. Reason why, I'm not sure. I don't know if it's the repellent. I don't know. But we did get better topical efficacy using pressurized aerosols, and other people have confirmed that too. They often kill within 120 minutes if you can get a direct hit, irrespective of how resistant the insect is. And some of these products also have great residual activity as well. So it's just another way to apply, but it basically does the same thing. Fumigants, obviously, this is something that only a professional could do. You have to have the special licensing that's really difficult to get. We try not to fumigate for bed bugs if at all possible, but I have been on site where people have done this. I was in an infestation once. There's probably 1 million plus bugs, and that's not an exaggeration. And really, the only option. It was an elderly assisted living facility. Everyone had to be evacuated, and they just decided to fumigate and kind of start from square one. The only thing that I think is, kind of a bummer about this method is that you don't get any residual control. So you need to really do it right the first time. It's typically going to be sulfuryl fluoride, which we're trying to cut back on the use of on I would say, a global scale. So we're looking at alternatives, but right now this is the number one compound used. Or I have seen people successfully use on like a residential scale the neem oil bed in a bag. I've seen mixed results, but I don't know. Maybe you guys can tell me if you have experience with it, because I've heard mixed reviews, but some people say they work great. I guess that's kind of a personal preference and a company preference. And we've already talked about dust. So dusts are a dry mix of an insecticide plus a diluent, usually talc or clay. They have, oh, sorry, they don't have I don't know why I put that. Talc or clay, they don't have a diluent in the same sense as like a liquid mix. Like you're not using water for the most part. Amorphous silica or diatomaceous earth. Some people say to spray them with a liquid, but again, I like to use it without adding any water or anything. I get better results just applying the dust. Silica dust, again, most efficacious in the field. You can put them out prophylactically or reactively. Synthetic actives should only be used reactively, in my opinion. And you can apply these with a hand puffer or a power duster. Impregnated materials, I've also seen these used by some companies. They are typically permethrin treated materials. Often these are in the form of like a mattress cover. They claim 24 to 48 hours of efficacy. Laboratory studies don't really reflect that claim. They don't support it. So I would consider other formulations when possible. Not that these can't be used as an addition, but if you've already got a pretty high dollar ticket, it might be something that you want to omit in favor of another better method. Current best practices, what can be done now? I don't think this issue is unlikely to go away anytime soon. Even if it's not actively getting worse and worse, it's still something I think we're all going to run into for the foreseeable future. I think an IPM strategy is best. I know this can be difficult, but if you can get proactive monitoring, I think that's great. We don't have a great active trap that works super consistently, but climb ups have been shown to work really well if you can get the customer to use them. Good inspections are crucial to make sure we aren't missing early introductions. You need to have a group of people that are in charge of decision making, and usually that's between an internal group of technical experts and then the customer. And then you need a management plan suitable for the customer and the extent of the infestation. The decision-making process for this pest, in my experience, is very subjective, very situational. But if you are looking for guidance, if your company doesn't have an SOP yet, or if things seem kind of all over the place and you want to streamline it, the NPMA does provide like a best practice guide that you can use. You also have all the tools that we've talked about in this presentation today. I think at minimum, like what I would call a top tier bed bug management program should have a proper detection tool, like a passive interceptor, so that you can monitor the progress of your treatment plan. It'll give you an idea of how many bugs were present at the start, and it'll help you assess whether or not they're gone. It helps you assess whether or not the treatment's working. To reiterate this, glue boards, because this is a question I get a lot, glue boards are not a good choice for monitoring bed bugs. I know they work great for German cockroaches, but bed bugs are repelled by most glues. And so they'll put one foot on the glue board and they tend to pull it off. And if the infestation is really dense, you might capture a few, but it is not the best way to monitor bed bugs. You also need to have a service agreement. This will set the expectation for both the technician and the client. Education of the client is crucial so that they know how they can help you. This is a joint effort. It's best if the customer cooperates in some way. And you can use some of the information from that education slide earlier. Non-chemical methods, if possible, the customer should be vacuuming, removing bugs when they're observable. If you're able to do this on site, it really helps. That starts to also reduce the amount of aggregation pheromone in the environment, which is attractive to bed bugs and puts customers at risk of new infestations as well. It also will help everyone involved distinguish between old and new aggregations and old and new infestations. And then chemical control methods, like we said, typically necessary, especially in a really dense infestation. If you can, try to rotate your products or use products that have greater than one active ingredient from 2 or more classes of insecticides to kind of circumvent that resistance issue that we talked about. And then supplementing with desiccant dust, great, because they're mechanical. And as far as we know, bed bugs are not resistant to those. Finally, the last step would be assessing the job. Are you still seeing insects in your monitors? Do you see insects when you do a visual inspection? Look for all the signs of activity that we talked about, especially doing that final infestation is really important. I'm a big advocate of, when you do your inspection, say you see no bugs and the treatment is complete, I would still come back one more time past that. So that way, if you missed, in a group of eggs or something really small and those hatch out, you've caught it early, you're not coming back 3 months later when there's another kind of full-blown issue. With that, I think we're all finished. We have about